These are tips for understanding Progress Book. If you see HWP in Progress Book, that means points per problem that you had right on a homework assignment for that day. It is out of 0, which means if you get all 10 right, you have 10 extra credit points. Anything out of 0 is extra credit. If you have a 0 for your score in this spot, it cannot hurt you. If you see lotto in gradebook, that's short for lottery, it is out of 0 points. If you don't have a score there, if it's just 0, it doesn't hurt you because it's out of 0. If you have 5 or 10 or whatever out of that, then it's extra credit points. You could have 10 or 20 in that spot because I not only lump in the lottery number, I also put in the bonus on the warm-up quiz if you add everything up for the final answer. If you see warm-up, it's worth 50 points. If you have a 0, it does hurt you. You can come in for 6th period and do that warm-up quiz and anything else you missed. When you're absent, this does not convert to 50 by virtue of your last name or your hair color or designer clothes. It is simply a 0 because I haven't seen your work yet. If you see HW, that's a homework assignment, which is not optional. It is out of 50 points. If you don't do it, for whatever reason, it's 0. If you don't go vote, they just don't choose somebody for you and dump it in the ballot box. You actually have to do some work. So when you do this, you'll get 50, even if it's late. But if you don't have it, whether you're absent or whatever, it's 0. If you see EC, that's short for extra credit. It's out of 0. It cannot hurt you. If you see practice, those are practice problems in class which are worth 10 points each. So if we do 4, it's out of 40. If we did just 1, it's out of 10. If we did 3, it's out of 30. But a lot of times I undercut the bottom number. For example, today is the first day of a new objective, so all practice problems will be still 10 points and bonus are 5, but it's out of 0, so everything's extra credit today, including the quiz. And then the next day we may go to 10 or 20 points like that. When you go to Progress Book, you have to click on the assignment so you can see how much it's worth. If it's out of 0, that's not going to hurt you. Fear, shock, and sadness set in whenever people see 0s all in a row in Progress Book. You must look at the bottom number. If it's out of 0, it's not going to hurt you. But if it's a homework assignment or a quiz and it's out of some point value, then you must do that at a later date. Let's move on. For today, to use a derivative to find a tangent line. To use a derivative to find a tangent line. Here's an example. The function is y equals x squared plus 3x minus 1, and we want to find a tangent line at x equals 2. First, you have to graph the function so you have an idea of what it looks like. So remember that the function is x squared plus 3x minus 1. To graph it easily, you can plug in some points. For example, if x is 0, what is y? Yeah, negative 1. So I go over 0 and then down 1. There's a point. And then if I put in 1 for x, what do I get back for y? I will get back 3. So you go over 1 and then up 3. You're plugging in points. What if I choose a 2 for x? If I put 2 in for x, what is y? If I put a 2 in, I go over 2 and then up 9. It's almost off the screen. I think we can just barely fit it in there. Let's go the other direction. What if you put a negative 1 in for x? What do you get back for y? So if you plug in a negative 1, you get back a negative 3. So you put a dot there. What if I put in a negative 2? If you plug in a negative 2, you'll get back a negative 3. And we can double check that. That would be 4 minus 6, and then minus 1 would be a negative 3. Plug in negative 3 for x. What do you get back? If I plug in -3, I get back -1. So I go back -3 and then down 1. What if I plug in -4? If I plug in -4, what I'm going to get back is a -3. With the points that you gave me when we plugged in these things, you can draw a graph that looks similar to this. The graph of x squared plus 3x minus 1. All we did is graph it. But what we want to find now is the tangent at x equals 2. When x equals 2, we want to find a line that is tangent to this graph. We came up with y equals 7x minus 5. So if I go -5 on the y-axis and then go up 7, 1, 2, 3, 4, 5, 6, 7, and then over 1, I now have a line that I can draw. Hopefully this comes out somewhat neat. And I can try to move it a little bit, and that one's not going to go. I can't use that line, so I have to draw it freehand. It won't let you spin it. So we started here, and this is going to be somewhat strange, but we started here, and it's not very straight. But it should go up through here like this, and it actually touches the graph at that one point. And that would be the tangent line when x equals 2. Here's an explanation of what tangent is. Here's a circle. If I drew a line that was tangent to this circle, it would touch it at one point and then go on forever. That is a tangent to that circle. If I had a graph like this, and I drew a tangent to it, one possible tangent would be there. Another one could be here. Another one there. It touches at one point and then goes on forever. This is what we're going to use a derivative for in order to find the equation of a line that is tangent to a graph at a specific point. Step 1 on this is to find the y-coordinate. For example, if x equals 2, I just plug in 2. And then go back and evaluate the rest of it. We did this one before, and it comes out to be 9. So you want to hold that. You now have x equals 2, which was given to you in the problem, and y equals 9, which we've just solved for by plugging in x equals 2 into the function. Now, next, you have to find the derivative of the function. So remember, the function is y equals x squared plus 3x minus 1. To find the derivative, we will end up with 2x plus 3, and the back end drops off. It is now gone. Once you get the first derivative, then you have to evaluate the first derivative with the given point. And remember, it was x equals 2. So if we do that, we have 2 times 2 plus 3. That's 4 plus 3, which will be 7. What you have just found now is the slope of the tangent line. You will find you have just found the slope of the tangent line. Now don't forget, and in a different color, x equals 2 was given to us. We found y to be equal to what? 5. And now we have a slope which is 7 in y equals mx plus b form. This should be 9. I said 7 and wrote 7. It should be 9. Yes, the y should be 9 and the m should be 7. Y is 9 and the m is 7. Now that we have x equals 2 and y equals 9 and m equals 7, you can use y equals mx plus b to go back and solve for the y-intercept of the tangent line. Y is 9, the slope is 7, and x is 2. So 9 equals 14 plus b. Move the 14 over, make it minus, and you end up with a negative 5. So don't forget the slope was 7. The slope was 7, and the y-intercept is negative 5. Slope 7, y-intercept negative 5. This is your tangent line, if we have done everything correctly. For this problem, all I need is the tangent line only, the equation of the tangent line in y equals mx plus b form. The solution for the practice problem is y equals 4x minus 4. We will do more work on the screen tomorrow, but we're running out of time today. We'll try these for tonight.